be about building private enterprise clouds using Citrix Cloud Platform. Your presenter today will be Marc Trouard. I can't say his last name properly.
Marc Trouard-Riolle.
There it is. He's a senior technical product marketing manager. He's going to walk us through the agenda for today. Just a reminder, we are recording this entire webinar. We will make it available, as well as the slides that Marc is going to be using. And within the slides, there's going to be some hidden slides that have a lot more detail than we're going to be able to cover in today's webinar. So with that, Marc, take it away.
Thank you for that introduction, Gene. It's worth pointing out as well that sitting in the room with us here today, we've actually got the Cloud Platform PM team working in the background to furiously answer all those questions that you're putting forward. So please do keep those questions coming through the chat window of the GoToWebinar panel. These guys are here just going to be answering all your questions throughout this session. If you want to tweet about this session, please do use the @Citrix or @Citrix Cloud tags. If you've got something really positive to say, please also use the @Trouard-Riolle tag, because I love to hear about all the positive stuff. We're just going to be talking about Citrix Cloud Platform, and that's powered by Apache Cloud Stack. So for those of you that are not familiar with it, Cloud Platform is the commercial product produced by Citrix that's based on the Apache Cloud Stack product that's in the open source community, the Apache Software Foundation. That's something that Citrix gave the Cloud Stack product to the Apache Software Foundation about 18 months ago. And that's now very much a very vibrant community there in the open source world, and Cloud Platform is based on that open source product. So what are the key takeaways that I'd like to, hopefully you will get out of this session? Cloud Platform really is able to deliver a comprehensive out-of-the-box functionality for your cloud orchestration layer, and hopefully you're going to see that and how easy it is to really get a cloud up and running. We're going to be talking about some of the operational, service management, and governance capabilities within the product, and really sort of trying to show you how some of our customers are deploying this to drive their real-world businesses today. And this is very much something that's been proven in production clouds in use. So this is a packed agenda, as Gene pointed out at the beginning. There's a lot of content here to get through, and so that you'll see from the slides that you're able to download afterwards that there's a bunch of hidden slides that I just don't have time to go through today. This masterclass should last approximately 1.5 hours in total, and to get through that, I've had to hide some of this content. A lot of this content has actually come from an internal training course that we deploy, that we use for deploying clouds in 5 hours. So I didn't want to do a 5-hour masterclass and keep you online for that long. So I've condensed this material down to show you certain aspects of it, and from the content and demo perspective. So we'll be talking about what is Cloud Platform, talking about the architecture and the infrastructure to support that, very briefly the demo environment that I'm going to be using today, talking about installing and configuring the Cloud Platform orchestration layer, and then very importantly about zones. And we'll be doing a demo of installing an advanced zone that you'll find out more about throughout this presentation. We'll take a look at service offerings, accounts, domains, followed by a short demo, and then working with virtual machines, templates, ISOs with a demo there as well. Very importantly, hopefully not the most important piece, but it's up there on the list, is the quiz and prize giveaway. So Gene will be taking that at the end of the session. Do keep an eye out for some of the points that we raise throughout this session, because there'll be a question for that quiz that you need to get right to get that prize. So let's jump straight into it.
So we'd like to start off with an audience poll, and we just want to get a feel for what are the use cases for your private cloud. So is it dev test, research or big data, high performance computing, scalable web services or disaster recovery, or all of the above? So we'll have the poll out to you. Check off those that apply. We'll give it about 30 more seconds.
So we've got lots of people answering already, which is great. And interestingly, it's very consistent with what we see in other sort of polls that we run along these the same lines. The dev test seems to be leading the way out of the interest of most people, how they can handle essentially their development environments, test environments, maybe do this with self-service so that your infrastructure admins can get on with other tasks rather than handling requests from the dev and test teams. So it's fairly consistent with what we've seen before.
It's almost exactly what we've seen before.
Okay, great. Let's move on. So lots of material to cover. If I talk quickly, don't worry, you will get access to these slides, so don't forget that. But there will be a few of these slides that I skip over fairly quickly. What is Cloud Platform? So essentially, it is your multi-tenant cloud orchestration layer. It's able to provide an open, hypervisor agnostic, and massively scalable, you'll hear me use that phrase a little bit today, orchestration layer. Essentially can help you run both private enterprise workloads and cloud native workloads. What do I mean by that? Well, if you think about traditional enterprise organizations that have been deploying infrastructure for many, many years, a lot of the workloads they run in those environments are more scale-up workloads. You add more resource to that workload. If it's a virtual machine or a physical piece of tin, you have more CPUs and RAM to get it to perform better. You might be, if you need that enterprise workload to be resilient, you make sure that you've got all the load balance NICs and redundant power supplies, etc., within that infrastructure. So traditionally, private enterprise workloads expect infrastructure resilience. Now, conversely, more recently, cloud native workloads, as we call them, are workloads that are designed to scale out rather than scale up. They're workloads that expect failure within your infrastructure. If you've got one web server, for example, that happens to be running across multiple different pieces of tin or multiple hypervisors and distributed throughout one or more data centers, then what's the issue if I happen to lose one of those web servers? I have the rest of that server farm that's able to take over that load. So they expect failure of that infrastructure, and as such, they're designed to scale out rather than scale up. So we talk about a bit of the difference there, and we're going to be focusing today on the sort of private enterprise workloads and building an infrastructure to support some of that. And importantly, this is very much an out-of-the-box infrastructure as a service cloud delivery solution. And you'll see that from what's included within the product. So what does it actually do? Well, it's all about abstraction, abstracting the network, the storage, and the compute nodes that make up your data center. It's providing a self-service portal so that your users can come straight into that portal and request resources themselves without having to go through an intermediary person, having someone in your IT department, for example, having to build VMs and network components or storage components when the whole lot can be done automatically. And if in case I haven't mentioned, it's very scalable. We'll talk more about that as we go through. So, scalable platform that can support tens of thousands of servers. And we have customer proof points of this where they are deploying this on the very large scale. But not just in one location. Clouds are all about being geographically distributed across multiple data centers, and this is all through one pane of glass. It's about being able to automatically configure your workloads for your virtual machines, the networking and storage components with them. It's about having a managed pool of internal virtual machine appliances that underpin and support that cloud. The sort of firewall routing services, DHCP, console proxies, storage access and replication. It's all about simplifying the installation and configuration of that infrastructure. We have a graphical user interface, two in fact. There's one if you're an admin, there's another one from an end user perspective. We'll touch on those a little bit later. And this is a UI that can also be customized based on your demands. There's an API that has API fidelity with Amazon Web Services. And this is very much the whole management features available in UI are making use of those APIs as well. So it's an API that runs throughout the design of Cloud Platform, if you will. It supports multiple cloud strategies. It supports your private clouds. These are your on-premise enterprise clouds that we're going to sort of be focusing on a little bit today. Dedicated resources, the security, total control, may be managed by third parties. This is conversely to public clouds that might be hosted by a public cloud service provider, or just making use of sort of multi-tenant public clouds. Might be where you've got more of a mixture of shared and dedicated resources. The hosted enterprise cloud and on-premise is all really sort of dedicated resources, dedicated either to the company or dedicated to the teams that are using those resources. So what are the key benefits? No vendor lock-in. I've already mentioned about Cloud Platform being based on the Apache Software Foundation open source product of CloudStack. It's open source, open standards, and you have a variety of choices, which I talk about in the next slide. The API fidelity with Amazon AWS all into this no vendor lock-in. You've got that API fidelity, so you can use some of the native tools that you already use with Amazon with your own internal clouds. It's very flexible, that it can handle these different workload types that I spoke about earlier, the traditional enterprise workloads and cloud native workloads. Enterprise workloads typically relate to the advanced zones that I'll talk about, where cloud native workloads talk about basic zones. So I talk about both of those during this presentation, but I'm going to focus on that sort of traditional enterprise use case. And this has very much been battle tested, as we like to say, in the real world with production environments today. In case I hadn't mentioned, it's very scalable. Tens of thousands of physical servers, virtual servers, geographically distributed all over the world. But importantly, all manageable via that single pane of glass. From the choice perspective, we have the ability to support many hypervisor types, both Citrix's own Zen server, Microsoft Hyper-V, KVM, VMware vSphere, and very importantly, bare metal. Might be more of a niche use case, but bare metal in the right circumstance with the right workload is the right choice to make. If you have a workload that can scale up and use all of the resources within that piece of tin, why do we need to have a hypervisor below it if we only need that one workload on that piece of tin? But very importantly, we want the ability to orchestrate and provision that workload on demand, and maybe then repurpose that piece of tin for something else if we need to on demand. So having the ability to provision bare metal is very important. From a storage perspective, we support everything from local disk, iSCSI, fiber, NFS, and object storage. We talk more about this and obviously the networking, where we talk about the network types that we support, various isolation methods, firewalls, load balancers, and VPNs as well. So let's jump into the Cloud Platform user experience. So I spoke about the two different UIs before. Here's the user console. You'll see compared to the admin console, there's less choice down the left here, and we've got this very sort of user-friendly interface here that's showing the number of running, stopped, and total VMs we have within our infrastructure, as well as some latest events and network events. Here's the administrator's console, and we can see that there's more choice down here, such as with the infrastructure, global settings, and service offerings. And I'll go through all of these later. This infrastructure tab showing us all the different zones, pods, clusters, etc. within our environment. Very much an admin type function. So what about monitoring the environment? Well, this is one of the monitoring screens that we have from the dashboard. We can see the different sort of workload types. These initial letters here do mean something. I'll go through those later. The type of workload it is, the zone that they are operating within, the running state, whether the agent's up, and quick view, which I touch on again later. We can see some high-level system capacity. We can understand straight from this screen that the London zone with London Pod 1 is running at about 39% of memory capacity. On this one, which is sort of delving a little bit deeper, maybe from a cluster perspective, we can see that the memory here is running at 81% utilization. So it gives us that ability to be a bit heads up, and start proactively planning to build out the infrastructure as necessary. Maybe just even adding memory to existing hosts so we can bring down this utilization level and scale out more on demand as we need to. The user-driven virtual machine creation wizards, that's a bit of a mouthful. Basically, this is a little wizard. It takes a very short period of time to get through, but enables you to very easily, very quickly create a workload for the appropriate zone within your environment based on templates or ISOs, the type of operating system. You get to select the container type, which is how many CPUs, RAM, and gigahertz or megahertz that you want, and the type of networking that's going to be used. We talk about this in more detail later. So the virtual private cloud, this is one of my personal favorite slides because it says so much. Basically, this is all really about being able to orchestrate complex end-tier applications and networks. If we think about the type of applications that enterprises are deploying, the traditional workload types, these are multi-tiers of application. In this example, we have a front-end web tier of these two servers. We have a middle tier of application servers and database. And then we've got, these are all being tied together on different VLANs, and the virtual router here is essentially 3 legs of one virtual router that's connecting these all up, being able to route the traffic as necessary between these different tiers. What we're able to do with the VPC is deploy these workloads into the correct tier on demand very, very easily and very quickly. So it handles all of the isolation that we need between the different tiering of applications and the orchestration of those workloads. Just for reference, and I'm going to come back to this later, you see here there's a Juniper SRX firewall and then NetScaler load balancer. And I'm going to talk about that later when we talk about the virtual router in more detail and options you've got as to the devices you use within your infrastructure. So user virtual machine management. We can do various VM operations from such as starting, stopping, restarting workloads, get access to the virtual machine console through a variety of mechanisms, see some statistics about our VMs, and also change the service offering. We can do certain volume snapshot management, adding and deleting volumes, creating templates, scheduling those snapshots to occur at certain times, and viewing the history on them. So let's talk about who uses this. I've spoken a lot about what it can do. Well, these are the organizations that are sort of deploying Cloud Platform today. In fact, we have over 250 customers that have large-scale production clouds already in deployment today. And these range across the service providers and telcos through to the enterprises, education, and government sector. Some of these customers, and this is actually an example of one of the enterprise customers, has over 40,000 servers in just one of their regions. And that I really want to emphasize. When I talk about 40,000 servers, I'm not talking about multiple customers making up that number. I'm talking about one customer in one of their regions has over 40,000 servers based on Cloud Platform, all managed from that one single pane of glass. In the service and telco side of things, we have organizations such as BT, KDDI, Bell Canada, all of these service providers that are offering public clouds to their customers based on Cloud Platform. On the enterprise side, some of those customers range from Disney Interactive, Zynga, TomTom, SAP, Autodesk, and USP, the University of Sao Paulo, are two interesting ones for us in our division. For the last 2 years running, at the yearly Citrix Synergy event, a Cloud Platform customer has won the Innovation Award, which is our prestigious award that is won by a single customer once a year, and the last 2 years running, a Cloud Platform customer has won it. Autodesk, and then it was this year, and last year was USP, for clouds that they have deployed in the enterprise or universities. And we have a large number of universities that seem to adopt Cloud Platform, from USP to RMIT to this university here in Japan as well. So let's take a look at the architecture and infrastructure. It consists of 2 parts, basically. We have the management server, and we have the infrastructure it manages. It's quite simple, really. I'm going to skip through this slide quite quickly. You can read all this later, but it provides that user interface, the API, and that single point of configuration and management for your cloud. So it's made up of infrastructure. We have our servers, our network, and our storage down here. And then we attach to Cloud Platform controllers, the compute, the network, the storage controller. We add an orchestration engine and a MySQL Cloud database to store all that data. And then we add the necessary business logic, the APIs and the UIs, and then our users and administrators are able to connect to that. So taking a look at that infrastructure, what does that consist of? Well, at the very small level, we have workloads. That workload might be either a bare metal workload, or more commonly, as most of the use cases lean towards, is using virtual machines based on some type 1 hypervisor. So your host is your single server that runs on a piece of tin, and you run multiple virtual machines on that. Now, in terms of scalability, whilst I'm here, I should emphasize that the scalability limits on a per host basis is very much defined by the hypervisor vendor's own scalability as to how many workloads you can put on there. But just because a hypervisor vendor says you can put 500 workloads on there doesn't mean you're necessarily going to get it. Obviously, it comes back to that, how long is a piece of string story? It very much depends on what you're trying to do with the infrastructure, how big or small those workloads are, how many CPUs and RAM you put into those workloads, how intensive the network and disk I/O is, and how big that piece of tin supporting it below is. But even speaking just from a Citrix Zen server perspective, we have proven up to 500 Windows workloads, 600 Linux workloads on a single host. But I can tell you now, we don't see many customers running up that high, purely because you need a very special set of circumstances to be able to get that, and a very, very large piece of tin to support it. Looking at the cluster level, a cluster level is a group of, as it says here, identical hosts. And I'll touch more on the identical comment later on. But essentially, all these hosts have the same hypervisor type and the same version, and you collate those together and add some primary storage. How many of these you can put into a cluster depends again on the hypervisor platform vendor's set of supported maximums. And this will vary from vendor to vendor. From a pod perspective, so if we think back, we've now got virtual machines on hosts, and these hosts go into clusters, and we have one or more clusters in a pod. And that pod is connected with other the cluster in the pod is connected to other clusters within that same pod by a layer 2 switch. And we like to say, think of the pod as a rack. It's a rack sitting in your data center with that layer 2 top of rack switch on it. So you typically wouldn't see more than 4, maybe 5 clusters per pod is what we tend to recommend. Now, when we talk about where pods go, well, they go into zones. And you can have lots and lots and lots and lots, and I could keep going on with the lots and lots and lots of these pods in zones. This is phenomenally scalable. Now, there are certain configurational aspects of zones that might cause you to want different zones. It might be that you want to dedicate resources at a zone layer, so you want to dedicate different areas of your infrastructure to different either internal tenants or maybe external tenants, which it might cause you to use different zones. It might be a certain configurational aspect that forces you to look at different zones. And that's what we're going to be touching on today with zones to cater for traditional enterprise applications. But at the end of the day, users can pick the zone where they want their virtual machines to be created based on what they have access to and where those templates are able to be deployed within the infrastructure. And that's all a part of the design. And we touch on little bits of this throughout the demo. These pods and secondary storage are connected with a layer 3 switch. I'll talk more about all these sort of primary, secondary storage in a moment. But each pod essentially is its own broadcast domain or network subnet. Now, we've wrapped that in this little purple house-looking object because a zone will often correspond to a data center. And we might have multiple zones within separate data centers. We could arguably have multiple zones in one common data center if needs be. But this is providing the physical isolation, redundancy, and can aid with compliance for an organization's data storage policies, things like that. Now, what's bigger than a zone? A region. So we start getting really big here. Now, we're always going to have a minimum of one cluster in one pod, in one zone, at the very least, and that one zone is going to reside in one region. But for some of our very large customers, they do have justification to scale out on the regions as well. And the way that they want to manage their infrastructure is that, in this example, we have an EMEA, an APAC, and a US region. 3 different regions. Each one of those would have its own management servers. It should be plural there, to really emphasize that you're going to be providing resilience within that for all those management servers. And these regions give you, a different way of having higher availability and scalability. Particularly if you think that you could be deploying some of your applications that transcend these different regions, is how you can get greater availability and scalability for your applications. So looking at things from a storage perspective, your clusters have their own sort of primary storage, and this is what stores all the sort of disk volumes for your cluster's virtual machines, your OS and kernel disk and any data disks. And it also allows you to move between the hosts in your cluster. So this is really where it needs to be shared storage, so you can very easily move that VM around. This is using the technology that you're all probably familiar with from your experience with traditional server virtualization, the likes of VMware vMotion or Citrix ZenMotion from our side. Now, this is typically built with high-performance hardware. You want that storage to still be around. If the primary storage fails, then your workloads are going to fail. But it's important to highlight that it depends on the use case. We have seen organizations that have put their primary storage as local storage. If the application warrants it, they don't want to base it on shared primary storage. So that's a perfectly valid use case, and you need to do really what's applicable for what you're trying to achieve. Shared storage, though, is is what's normally recommended, and that would typically be based around NFS, iSCSI, or fiber. Now, from a secondary storage perspective, every zone, I should say, has secondary storage available to it, and that's available to all the hosts within the zone. This stores templates, ISO images, snapshots, and it must be NFS based if it is anything other than Hyper-V, because if it's Hyper-V, you can then use the SMB or CIFS. There is an exception to this as well, in that if you want to use region-wide secondary storage, then that would be object storage based. This is what a typical cloud platform architecture might look like. So we've got a couple of availability zones. This could be within one site, it could be more likely across sites. We have a number of pods listed here with that top of rack switch. Pod ends just really emphasize the scaling out of that. We have some secondary object storage here. A layer 3 core switch that's connecting all these together. Load balancers and routers for the outbound communication to the public network. And then from a management perspective, we have our switch, a MySQL database that's going to be resilient with a cluster of primary management servers, again, for resilience purposes. And to load balance across those, we'd have a load balancer so that any cloud operations admins that come in, they get load balanced across these, however many here are in this cluster. So let's take a look at the demo environment that I'm going to be using today. Very small sort of basic demo environment, but it does the job. We've got a management server here on this IP address of 10.15, an NFS server that we'll be using on 10.12. There is a Citrix NetScaler VPX and some Microsoft Active Directory in there, but not really going to be using those so much. We focused around this Zen server host number 3 here. And we've got the 2 networks, our sort of management network and our public guest network here in the advanced zone. And I'll show you that from both the infrastructure side and the cloud platform side as we go through the demo later. So let's take a look at installing and configuring cloud platform. So I've mentioned already that the management server is really what's giving you the ability to orchestrate, manage the infrastructure, and it's provided through administrative web UIs and APIs. The one thing I want to emphasize is that this is all scalable. So you can scale these out with multiple instances of the Cloud Platform Management Server, and you'd stick a load balancer in front of those to load balance across those, and you can also make the MySQL database resilient as well and highly available. Now, a single management server can manage anywhere up to around 10,000 hosts, and this could be in multiple availability zones, multiple data centers, etc. But a cluster of them can really start to scale up to 100,000 hosts, and that's all again from this single pane of glass. I won't dwell on these slides too much, just emphasizing the management server requirements. You can see all of this from the various install guides for Cloud Platform, and likewise on the host hypervisor system requirements. We always recommend that you must absolutely meet the hypervisor vendor's minimum set of requirements. Here's some for the Citrix Zen Server product. But we tend to recommend that whichever version you use, make sure it's patched up to the latest with all the hot fixes, and they should all be common across that hosting infrastructure. We talk about clusters being homogeneous, and I mentioned this earlier about them all being identical. Well, that's to a degree. I mean, the fact is that what you want are all the CPUs to be very similar and have the same set of feature flags available to the workloads. What you can't have is a mixture of different CPU types in one cluster. You can't say, I'm going to have half my cluster on Intel and half of it on AMD, because it's just not going to work. What you can do is you can mix CPU revisions and the CPU count to a degree. But if you've got different feature flags available within those different CPUs, what you need to make sure is that you use CPU masking to, and I hate this phrase, but I'm going to use it anyway, dumb down those CPUs to the lowest common denominator across the CPU types. Because what you don't want is a VM running on one particular host on a relatively new CPU that you've just added to a pool, and you then decide to move that workload to another host that doesn't have the same set of feature flags within the CPU. If that VM is making use of any of those feature flags and you move it to another host, guess what? That VM is going to fall over very quickly, because it suddenly can't see aspects of the CPU that it had just a moment ago. This is why you need to sort of, we use the term identical, or that the cluster must be homogeneous, but basically you can mix and match them as long as you use CPU masking so that you mask out any differences between those CPUs. So what about system VMs? Well, Cloud Platform uses a group of different system appliances or system VMs to perform various aspects within the cloud. There's the console proxy VM, secondary storage, the virtual router VM. Essentially, Cloud Platform manages all of these within your infrastructure. It manages the creation of them, starting them up, making sure they're in the right place in your infrastructure, stopping them as needed, based on the scale and what you're trying to do at the time. The proxy VM specifically is all about presenting a console via the web UI to that user, that admin, or the user that's trying to gain access to that console at the time. The storage system VM basically performs a few tasks. It's about importing or registering new templates to a zone, exporting them from a zone, maybe copying templates between zones, for example. The virtual router system VM is a very important one. It performs a lot of tasks around offering DHCP, DNS, load balancing, VPNs, firewalls, you name it. Lots of very important services that your virtual private cloud is going to require. Now, with some of these, as I emphasized earlier when I showed you the virtual private cloud slide, some of these you can swap out for other services in your network. If you've got a large enterprise infrastructure and you want to go beyond the scaling of what the virtual router within Cloud Platform is going to offer, and maybe offer certain extra functionality, it might be that you want to use a Citrix NetScaler for your load balancing services, for example. Or it might be that for the firewall, you in fact want to use a Juniper SRX firewall. So there's lots of choices there as to using the Citrix inbuilt Cloud Platform functionality, or using other Citrix technology, such as the NetScalers, which come in 3 different forms, from VPX, MPX, and SDX. I'm not going to talk about that too much, but if you're interested, certainly go out and Google there. There's a lot of information out there on the web about those products. Or it may be even looking at products from some of our third-party vendors as well. Importantly, there is one of these virtual routers per network within your infrastructure. So the system VM template is basically used to create all of these system VMs. And the zone must be seeded with one of these different templates for each hypervisor as necessary. So this is done on the sort of essentially on the creation of that cloud platform zone. So let's take a look at zones. So from a networking perspective, the cloud platform guest VMs communicate using a shared infrastructure. If you think about what it's like within your virtualization infrastructure, quite likely you have a few networks bound together on the host, and all your VMs communicate out on that shared infrastructure to get access to the outside world. And as soon as you start adding multiple tenants within that infrastructure, so this might be tenants from the perspective of a service provider, it might be tenants from the perspective of internal tenants, different divisions within my one business. They're all sharing that common infrastructure to gain access to the internet. So we need ways of being able to isolate traffic. And essentially, the different tenants, in this case here, we've got John Glenn that has 3 VMs, and Sally Ride has 2 VMs. They have the perception that they're on a private network. And this is done through 2 different ways of handling the isolation. First off, basic zones. With a basic zone, all the guests share a single network, as you see here. But the guest VM isolation is provided through security groups. IPsec and IP groups and things like that are handled at the network layer within security groups to give the perception that they can't see each other. I tend to use the analogy that you've got lots of people walking down a path, but you can't see the other people walking down the path. You're sharing that path together, but you can't see each other. That's essentially what's happening here with the security groups. You're sharing that common infrastructure, you just can't see each other. Now, the basic zones are what's more commonly used by service providers for the cloud-native workload types. They are very, very scalable. Tens of thousands of VMs and different tens of thousands of tenants, essentially. And these are very quick to create within the infrastructure. Interestingly, they are only supported by Citrix Zen Server and by KVM. Like I say, very popular with service providers and particularly for the cloud-native application types. Now, I don't want to say they're only used by service providers, because what we're seeing more in the last sort of year or two are enterprise organizations that are rewriting certain application types within their business as cloud-native application types. So it's very, very plausible to say that an enterprise will look to have multiple zone types within their infrastructure. Maybe some of the enterprise workload zones for the traditional application types, and maybe some of these basic zones for more of the cloud-native application types. Advanced zones is the other isolation mechanism that's basically using VLANs to segregate that traffic between the different tenants. And again, a tenant here could be just that. It could be a person or a group of people within a department or a different customer from a service provider perspective. It could actually be a set of applications. I spoke about the VPC slide where you might have segregation on the applications for a multi-tiered application. So do think about isolation, and when we talk about VM isolation or tenant isolation, that term can be applied to different things, people or applications or infrastructure, whatever you want to use for it. But here we're using VLANs, and you can see here the John Glenn tenant has 3 VMs in it, and the VLAN 103 is being used to isolate his traffic out onto the public network versus Sally Ride's infrastructure, which is using VLAN 114 to isolate her. So advanced zones offer many features, and we listed all these earlier. I mean, these are really only available from the advanced zone. The port forwarding, network ACLs, source, static NAT, gateways, firewalls, VPNs, etc. So these are some really big benefits to the advanced zone. For practical limitations perspective, VLANs, as I'm sure you're all familiar with, theoretical number of 4,096, usable number of 4,094 VLANs per network. And so for that perspective, enterprises have been quite often fitting within those limits in their network for years, and they're very familiar with using these. But when you converse this, compare this, I should say, to basic zones, where some of the service providers have tens of thousands of customers, they need something that's more scalable than VLANs and very quick to deploy. And that's why quite often they'll use the basic zones with security groups. So what are the traffic types? Public, guest, management, storage. So your public network, your public traffic, I should say, is when the guest VMs are accessing the internet. So here we see it from that virtual router outwards towards the internet. Your guest traffic is from between the guest VMs and to the virtual router. So it's what they're using to communicate between themselves. Management traffic is just that. It's traffic that's used for the infrastructure that's used by Cloud Platform for internal resources to communicate with each other. So the different hosts between the Cloud Platform servers talking to each other, NFS servers as well potentially. Storage traffic and network, but that's again through a secondary storage system VM. We'll talk more about this afterwards. And these are sort of transferred from the secondary to the primary storage. Snapshots are saved here. So if you've got a virtual machine running here and you save a snapshot, that's going to be transferred out here to that secondary storage. Looking briefly at the basic zone, I'm not going to dwell on this too much because we're going to focus on the advanced zone as our isolation technology using VLANs. The basic zone has one physical network called the guest network, and this carries all three traffic types: the guest, the management, and the storage. From an advanced zone perspective, we can see that the public, the guest, the management, and the storage are handled all separately across different networks. So, time for a demo. Let's change things up a bit. This is the first of hopefully 3 demos. How are we doing on time? Okay. So we're going to create an advanced zone now live based on this infrastructure. So let me jump across to, so we can see that infrastructure. So I very quickly want to touch on the environment we've got here. So these are the 2 zones we've got. This is looking at this from the Citrix Zen Server product managing Zen Server hosts. We can see there are 2 hosts here in the Paris cluster and 1 host here in the London cluster. And looking at this one particular host, we can see there's a couple of networks, management and public guest. So if I go to the Cloud Platform Management UI, I'm going to log in here. I'll get my login credentials right. So we've logged in. We can see our dashboard here. These are the options that's available to me. I've logged in as essentially the cloud admin of that root infrastructure. So we can see everything from our dashboard, the general alerts, host alerts, some of the system capacity. You saw some of this earlier on. We can see what instances are currently deployed. This is a demo environment. There's nothing yet deployed. Any affinity groups for ensuring that workloads go to different infrastructure types. So we've got a host anti-affinity rule here. Some of the storage, the networking, system templates that are deployed here. They're all currently deployed in the Paris zone, and you'll see why for a second. Any events, projects, I'm not going to dwell on these too much. Accounts and domains I'll come back to a little later. I'm going to focus for the moment on the regions, on the infrastructure tab. And we can see that we have one zone, Paris. So that's why when I looked at the templates, there were only templates there from the Paris zone. We can see that it's a basic zone, public, connected, and we've got that in an enabled state. Looking at the quick view gives us a few immediate things that we can do. We can sort of add VMware Data Center, disable the zone, dedicate this zone, delete the zone. If I go back to this infrastructure tab, I can look at the pods. I can see that this is the one pod that's available, the clusters that are available. So it's the Paris primary cluster 1, and the fact there are these 2 hosts in there. Oh, wrong button. Okay, so let's jump in and start adding a zone. So I want to add an advanced zone here. And I need to fill some of this information out, so please bear with me while I type all this out. So some of this is obviously going to be predefined by the environment that I'm trying to build. Some of these IP addresses, like DNS, gateway addresses, things like that are all going to have been given to me by the network administrator that I can use for building out this cloud. Here we can see the network types. So what I showed you over here on this particular host in ZenCenter, we have two networks available to it on two different physical networks, NIC 0 and NIC 1. We have a management and a public guest. So management traffic is going to be over this one, and all public and guest traffic will be over this network. So I need to reflect that here on this infrastructure. So I need the public and the guest to be here. I need to rename all of these. Copy and paste. Now I want to emphasize here as well, where it says edit traffic type or the Zen server traffic label, that's actually the network label over here. So it's just it's a slight difference in the terminology, but when we talk about the labeling, it's this piece here that we're referring to. So I just populate these out here to make sure they're all the same. Click next. So here now I need to enter some of the public traffic zone information. So here I've got 10.200.41.1 as the gateway. The mask is 2.555, so it's a class C. The start IP is 150. Now I add that. Let me just check that's correct. 1041. Okay, that looks correct to me. So click next. So now we need to enter information about our pod. So what's the pod that we're going to be using here? So the pod name is London Pod 1. The IP address here reserved for the gateway is 10.1. Mask. So this reserved set of IP addresses here is all about the cloud platform virtual system VMs. So it needs some IP addresses that it can dynamically assign to some of the system VMs that need to be created to help support this infrastructure. So I'm just going to give it a small range here within a suitable network. The VLAN ranges, so the VLAN ranges here, again, these are for communication between the guest virtual machines. So it's 150. Now we're going to enter the cluster name. Call that cluster 1. We can see that's based on Zen server. We need to enter some information about one of the hosts here. So just give that the IP address of that host. I need to log in. Host tags I'm going to talk about later. When we start talking about service offerings, I'm going to come back to what we can do with host and storage tags at a later point. So just sort of park that for the moment, and we'll talk about how these can be used, although I'm not going to enter anything for the purpose of this demo. So we're now at the primary storage. Again, this is where we're going to store all of the virtual machine OS and kernel disks. So here I need to enter the correct. Oh, no. Name London primary cluster 1. Server IP address is 10.12. So the path for this is NFS. So I'm just, you would get all this from your storage guy in your organization. Here I happen to be using a virtualized NFS instance. That's the path for my storage. Again, storage tags, park that, we'll come back to that when we talk about service offerings and how they can be used there. In fact, it helps. That wouldn't have worked if I'd spelled that incorrectly. NFS London Primary Cluster 1. Yeah, that's good. Secondary storage. I spoke earlier about some of the secondary storage offerings. NFS is zone-wide storage for all the hypervisors. On this, you've got Hyper-V, in which case it'd be SMB and CIFS. Or if you're going for regional storage, a region level storage, it could be, for example, S3 block storage. So I'm going to select NFS, and then I enter the name. I can leave blank. 2.168, 10.12, and the path to this is NFS London secondary. Next, so we are ready to launch the zone. It is really as easy as that. It's taken longer for me to type that information in and explain it to you than really it has to create the zone. So this just takes a very short moment to go through, configure all the physical networks. It creates the pod, the public network traffic, the cluster, etc. So as soon as this is finished, I'll jump back to Zen Center and show you a few of the little bits that it's actually created. And hopefully you're all still awake out there listening to me just talk away. Great, there we're done. Zone created. How easy is that? So we can see that's now listed here. I want to quickly just jump back to Zen Center and show you here that on this London cluster one here, we've now got some new storage that's been created, and we can see there's some new network. Now the Cloud Link Local Network is all about providing the secure communication between Cloud Platform and VMs and the Zen Server host. So Cloud Platform has managed creating sort of this network and these storage devices and things like that. Now what's also happening in the background is that it's going to be creating, if I go into that London zone and to the system VMs, it's now creating certain system VMs that's required for the console proxy and the secondary storage. So it's going to automatically provision those on one of the hosts within my cluster. Well, okay, in this example I only have one host, but it's going to make sure they're in the right area and that those are then provisioned automatically so that someone can start deploying workloads very quickly. This will probably take about 6-7 minutes before these register. So what I'm going to do at this point is jump back to the presentation and continue with this before we start the next demo piece. So let's take a look at service offerings, accounts, and used domains. So a service offering essentially defines the virtual machine's characteristics and capabilities. Compute offering, disk offering, and network offering. And this sort of bound together basically makes up a guest workload. And there are 4 different types of service offerings that we have within Cloud Platform. There's the compute offering. It enables us to define the CPU core count, how much megahertz in processor speed, the RAM. It's essentially that digital virtual hardware, if you will, that's used to run those guest VMs. And here's some examples here of different core counts, megahertz counts, and RAM counts across different instances. You would create these based on what you want to offer to your internal or external tenants in the offerings. From a disk offerings perspective, this defines the size of the disk used for those guest VMs that are created from a template. This is for the data disk, or the size of the root volume used for guest VMs created from an ISO image. And we can see some different ones there, including a custom disk size, if enabled. Not always enabled, but if it is, as you can see here, it's not enabled custom on here, then when someone goes to deploy a workload, as you'll see when we go through that portion of the demo, you can actually specify something that's out of the ordinary in terms of the disk sizing. Network offerings describe the virtual router features that's available on that given guest network. And that could be like shared, isolated, maybe it's powered by NetScaler, be it a VPX, an MPX, or an SDX I mentioned earlier. And that's all customizable through here. The system offerings is basically used for configuring the virtual infrastructure resources. So this is something that's obviously only visible from a Cloud Platform admin side, but we can see the sort of different system offerings for whether it's the console proxy or a load balancing VM, etc. So changing the compute offering, basically the compute offering used by a VM can be changed first off, but it depends on the state of that VM. While the VM is in a stop state, a user can change the VM's compute offering to any other available offering that there is. If the VM is running, you can only change that compute offering based on something with the same or more cores or with the same or more RAM. Obviously, most workloads don't like to sort of be midway running through something and have CPUs removed from them. which is why it's set like this. You know, if you start reducing the amount of RAM inside a machine, and that RAM that's probably storing certain content for that running virtual workload is not going to behave very well if you've suddenly taken that away from it. So there are some limits. You know, things I want to emphasize here. A guest with a service offering of 1 core will have the use of that entire core if there is only that one guest on it, on that workload. Oh, sorry, on that host. Additionally, yeah, if there is a yeah, if they've only got single guests on that host, you know, it'll have full access to that clock speed regardless of how much megahertz you give in that service offering. So, you know, in that service offering, we could have specified just 1,000 megahertz, yet actually the host, each CPU was capable of, say, 3 gigahertz. If there are no other VMs there, it'll have full access to everything. It only really comes into effect when you've got multiple VMs running on that same host. Now, very importantly, understand when we say 3 gigahertz or 2 gigahertz, exactly how many megahertz, because when we specify the of compute resource, it's done in megahertz, and if we just say, oh, 2 gigahertz is 3,000 megahertz, sorry, 2 gigahertz is 2,000 megahertz, if I get my words straight, that may not actually be the case. And you can check this in Zen Server. You can check this through the /proc/CPU info to get an exact understanding of what the CPU in megahertz is available on that particular host. And you should use that number as the maximum amount you use on that compute offering. If you use beyond that amount, in this case use 2,000 megahertz, when in fact there is only 1,997, then you may get a scenario where Cloud Platform is unable to find a hypervisor with 2,000 megahertz in that single CPU. So it might fail to find a host. So just bear that in mind when using this feature. It's also possible to dedicate resources. Very, very useful for organizations where, you know, if you're offering a public cloud, you might want to dedicate an entire host, an entire cluster, an entire pod, an entire zone to a particular user or account. It might be, or you know, maybe even a domain of users, and we do touch on this in the demo. It might be that from a private enterprise use case, I've got a particular department within my business that wants to be firewalled off and have no one else for legal reasons that have access to that host. We've seen a lot of this, you know, where you use Chinese walls to set, you know, boundaries around certain infrastructure for legal and compliance reasons. And so this is one way of being able to carve up that infrastructure. You know, it can improve scalability for that particular tenant if they know that they've got a dedicated amount of resource to them that they can scale up on demand and use it. Whereas if it was all being used by lots of different tenants, you know, in theory you could maybe find that they come to scale up, but that hosting infrastructure is also being used by other tenants, and there is nothing spare. But you've got to bear in mind as well that, you know, there's pros and cons to this. If I dedicate resource to one tenant, there could be another portion of the infrastructure out there that needs scalability, that can't get access to that hardware, and therefore I maybe need to provision more hardware dedicated to the rest of the cloud, and it causes me to have underutilized infrastructure within my cloud. So, you know, pros and cons, you need to look at what your business requires as to what is the best route for you to use here. But I'll talk a little bit more about this in the demo afterwards. From an account, users, and domains perspective, you know, an account typically represents that customer, and they form these sort of isolation blocks, if you will, and you can have admins for an account, and it's a way of sort of separating out different parts of your infrastructure within your cloud. So you can have one overriding cloud across your business, and then you can have different teams within it that have access to certain portions of the infrastructure they can manage themselves with their own admins for that, and things like that. And I'll show you how that's done in the demo as well. This shows it in a little bit more detail. Hopefully this is clear. We have our cloud root here with an account, multiple users in it, and also an admin account here. Then we've got a couple of subdomains, in fact one subdomain and one subdomain, or child domain of the subdomain, each with their own accounts, multiple users within them, and their own admin accounts. And there could be multiple accounts within any one of these domains. Anything here by this admin can manage everything in this cloud because he's up here at the root level. This admin for this first subdomain can manage everything in his domain and also his subdomain. And then you've got another admin down here that can only manage stuff at this level, be it users, accounts, and maybe infrastructure. So accounts and users can be provisioned by the UI, by manually filling out these dialog boxes, by maybe using an LDAP or Microsoft AD server, by using the Cloud Platform API, I should say, and it's also possible to use LDAP user authentication as well if needs be. So let's take it to another audience poll. I'll hand over to you, Gene.
Sure. Let's do one more. What is your biggest concern with implementing a private cloud? Is it the cost, security concerns, not knowing which applications will be best to deploy in a model, the lack of skills within your organization, or is it something other than that? So we'll give you about 30 seconds to complete this. And on this one here, it's not multiple, it's what's your biggest concern.
Okay, so interesting. So we've got a different response this time from what I think we've normally seen. Most people here are sort of putting cost as being the primary concern, but actually, interestingly, in the past we've seen lack of skills. So hopefully, our word is getting out there, and the training courses that we offer is resolving that lack of skills question. But certainly, cost seems to be the key thing there.
It's also surprising that security is the lowest.
Yeah. Okay, let's move on.
Okay.
So we'll jump straight into the sort of users domain service offerings demo. So I'll jump back to my demo environment here. So we're logged in as that admin of the cloud, as I mentioned earlier. We've got these offerings, these tabs down the side. I'm going to start really with the domains tab here. So this is the root domain that we were talking about, and there's one current subdomain here. I could add another domain here called my company for mycompany.com as the network domain. And if I refresh that, we can see that's now available. I could even add in here a few different subdomains. I might have an HR subdomain. I might have a finance subdomain. Remember, this is just one way of carving up this infrastructure. It could be that I carve it up in a different way based on certain application types. If the way that the business operates is based around specific applications or products or things like that. So if I just refresh that, so we've got these different domains, and now what I can do is view accounts. There's no accounts in here. I've just created this. I'm going to create myself an account here. Marc TR, my very secure password. Marc TR at mycompany.com. Just enter all this info. We can specify the type of user. I'm just going to be a user here to show you that panel. It's a little bit different. We can specify time zones, network domains, things like that. So that's now created that. And if I go to the Accounts tab, what we can see is all the list of all the accounts that we have within this infrastructure type that I have access to as this particular admin. Remember, I'm the root cloud admin here. If I was an admin of a particular subdomain, I would only see what I'm able to see within that portion of the infrastructure. Okay, so whilst this is a short list, if I'm managing a very, very large domain with thousands of users, I don't necessarily want to see everything here. But if I was an admin of just a portion of that overall infrastructure, I'd be able to see the users that I have access to. And I can do things like add LDAP accounts and things like that. And here's the account that I just added as a user of that dev domain here, and it's all enabled. From a service offerings perspective, here are the service offerings. We've got compute offerings here from mini, small, medium, and large, and the available description of what they offer. System offerings, elastic, load balancing, virtual machine, software router, console proxy. Disk offerings, small, medium, large, and a custom disk offering. we can go into here and we can see the various information about what that offering has, any specific rates, limitations, disk sizing, etc. The custom one, and then the network offerings. And here's the different type of network offerings that we've currently got enabled within our infrastructure. If I was to create a new offering, I'm going to call it XXL offering, extra big. Specify the storage type, whether it's custom, the number of CPU cores. Let's go for that. Let's say CPU megahertz, 2000 megahertz. I'm going to go 8192 because it's extra big. I could specify any limits here on sort of disk rate and stuff, whether I want HA enabled, the storage tags and the host tags. So this comes back to what I was talking about earlier in storage and host tags. If I want to guarantee that a particular offering, service offering that I'm creating goes to certain aspects of the infrastructure, when I added those hosts, if I've given them host tags, or when I created the storage, if I've given them storage tags, then I now can create my service offering to ensure that anything that's this particular service offering always goes to that portion of the infrastructure. So it's still common infrastructure. That infrastructure could still be being used by other service offerings that aren't making use of those host tags. But what I'm ensuring here is that this service offering will absolutely only deploy to that particular set of infrastructure. CPU tags, information around the deployment planners and planner modes. I won't go into that right now. And so here we are creating that extra big offering. Now, I'm not actually sure that I have a host that could handle that anyway, so I'm not going to create something from it. It was just to demonstrate that we can create that type of offering and the process of doing so. And that would be immediately able to be used when we create the VMs, which we'll go through in a second. The last thing, I'm going to jump back to the domains just to show you something else in here as well. So if I expand that out, so at the moment we don't have any limitations that's been placed on this. Now, the root domain here, we can specify the number of instance limits, public IPs, volumes, templates. There's a big long list. I don't need to go through all of these. But the point being is that at any point throughout this logical domain infrastructure, I can apply restrictions to the people within that domain. Now, if I was down here at the dev domain, at the moment I don't have any limits, but really, I know that character Marc Trouard, and he's likely to start using a lot of that infrastructure if you give him the choice. So rather than -1, I'm going to say, you know what, he can only deploy 10 instances. And in terms of CPUs, he can only deploy 2. In terms of the amount of storage in gigabytes, I'm going to limit it to 100 gigabytes of secondary storage usage, because otherwise that guy Marc Trouard is going to start consuming all the resources. This is very, very useful when we start creating dev test clouds, which you all seem to highlight earlier as being one of the primary use cases for your enterprise clouds, in a way that I can now ensure that my dev, Marc Trouard, has the ability to create his own workloads in his own sandboxed environment, but I'm placing certain controls over what he's able to do. I want to give him free rein so that he doesn't come to me and say, can I create a new workload for him because he's running out of space or whatever else. But I need to say, you've got limits as to what you're able to do, but go off and create everything yourself. So if I was to apply that, I can then see those limits that have come into effect immediately. Now, these are not limits that would apply to any other domain. It's just the domain there and down that I've really applied these to. Okay, at this point, I'm going to jump back. We've got about 15 minutes left. I've still got a little bit more work to do. Hopefully, we'll have time for some Q&A at the end. I know, very importantly, Gene wants to make sure that he gives away that gift card that we've got as a prize. So I'm going to skip through this virtual machines bit fairly quickly, show you the demo of that, and then we'll get into the summary. So a user can make a variety of choices when deploying a new virtual machine. We can specify the zones that we've already covered. We can specify whether to create from a template or an ISO image, the template style, i.e. what sort of workload it is, and these might be featured templates, templates from the community, or even my own templates that I've created. Specify the compute characteristics. These are the service offerings that we've created here, and these are where you could come in. And remember, we could create certain service offerings for certain domains in our infrastructure. So we can really tailor it down very, very granular if we want to. You know, certain service offerings on certain infrastructure just for certain portions of the infrastructure that we're using for our different teams and business units. Disk offerings. This is here the disk offering for the data disk, a secondary disk beyond the OS and kernel disk. Any CPU affinity that we want, or sorry, VM affinity, I should say, making sure that we can keep workloads apart. If we have multiple VMs of the same type that we want to ensure run on different parts of our infrastructure, this is where we'd specify the affinity here. Any network or security group isolation, this is used for, if I jump back to that, that's used for sort of basic network isolation. And virtual machine names. So let's just take a look at the virtual machine names. All the guest VMs have a name, but it's optional. If you choose not to create a name, one will be created for you. Something like this. So you know, if you want to easily find the workload names that you've created, give it something yourself. You can add it to a group. Otherwise, you will get something like this. Having said that, every VM also has a display name. And it just defaults to the name entered in the wizard, but this name can be edited by the user after the VM has stopped. And it also has an additional virtual machine name that's used specifically by Cloud Platform. And this is only really visible from that admin console. So you might have seen some of these VM names earlier in earlier screenshots in the demo. And this really basically is the naming here is defined by the type of workload it is. So first letter I, if it's a guest VM that a user or an admin has created. R is for router, virtual router, or for my American colleagues, I should probably say virtual router.
Oh, is that what you're talking about?
Yeah. Apologies for the accent difference there. I've just realized I'm saying it. Hopefully you all understood me earlier. S for the secondary storage VM, and the V for the console proxy system VM. Okay, so this makes up the name used for internal VM naming by Cloud Platform. Second digit admitted for system VMs. You know, it's 2 for admin, 3 for the first account, for the secondary account, and so forth. The cloud-wide VM number starts at number 3 because the first 2 workloads are actually provisioned by the system, and so then, you know, first VM starts at number 3 and fourth, so forth. So looking at the provisioning process, the user selects the template, the service offering, clicks launch VM. The Cloud Platform infrastructure then finds a suitable host where that VM will fit, transfers that template from the secondary storage to the cluster's primary storage. And then a VDI is created from that VM using essentially a linked clone. The VM is started on the selected host using that newly created VM. All subsequent VMs come from that same template, again, via linked clones. So looking at the life cycle briefly, we have a template, we create that into a disk image, we start that into a running VM, we can stop it, we can reboot it, we can reset that disk image from the template if needs be. It could fail, at which point we can restart it. We could destroy that VM, and we can restore it as well. So instances, VMs, workloads, I've probably intermixed all these terms throughout this presentation, but you know, an instance section shows the status of all the VMs owned by the user. And this list, importantly, can be filtered as well. So for larger infrastructures, you don't have to go wading through lots and lots of VMs to find yours. You know, you can search things, you can filter things as well. You have the VM control. So I showed you briefly the quick access earlier in the demo. You know, when you hover above this, a quick access or a quick view panel comes up, and it provides a list of options, you know, such as stopping, rebooting, attaching ISOs, looking at the console, a whole series of different things based on whether you're the cloud admin or a user as to what's on offer here. High availability, I showed you that in the demo as well. So selecting this, HA enable VMs, you know, they are monitored by the system. So if the system detects that HA VM is down, it will attempt to restart it. If you do need to shut that down, you do need to shut it down from Cloud Platform, not from within the guest. Otherwise, Cloud Platform will just keep trying to restart that workload. So accessing the VM, one of a few different variety of methods via the GUI to get access to the VM console. You can also RDP into things as well if you need to. That's obviously based on what's available inside that guest. Looking at the tab details here across the top, I'm not going to step through all of these. There are some hidden slides, I think, on this that you'll be able to see when you download the deck. But we can see the state of the workload, what template was used, various compute offerings, zone, domain, account, etc. There's some best practices as well. You should always have the agent tools for that given hypervisor you're using installed within the guest. And this does impact what you're able to do within with that guest from an admin perspective. So making sure you're able to make sure you've installed the VMware tools or the Zen server Zen tools really enables things like live migration, dynamic scaling, live view for VMware only, things like that. So importantly from a Zen server, you don't have the Zen tools installed, and I think this is similar for VMware. You'll find you're using emulated drivers. If you're using emulated drivers, you won't get the performance of I/O for storage and network. So to make sure you get the best performance, make sure that you've got the Zen server tools or vSphere tools installed inside those guests. The usage limits I've gone through here. I'll skip through this slide. We covered this already. I spoke about live migration earlier, which was live migrating just the compute aspect of a workload within a cluster, but we can also live migrate more than that, such as the compute and the storage from one cluster to another cluster. Very useful if we know that we're going to be decommissioning this cluster one here over the course of the next few weeks. I can migrate all the workloads from here somewhere else, and then I can decommission this cluster. It may be, for example, that hardware has gone end of life within my data center, and I want to be able to remove it from within my infrastructure without impacting the runtime of those workloads. It might be that I just want to move some storage. It might be from the primary storage to local sort of SSD storage. This enables us to offer tiered storage within our infrastructure. The VM stays running during this process. I'm just moving the back-end storage that it's using from one tier to another. So a great way of being able to re-tier storage for our running workloads, again, without impacting that workload at all. Looking at working with templates and ISO images. A template is the sort of file that contains your VDI disk image of the boot. So it contains that OS image, whether it's Windows or Linux or something else. And it contains everything that you have defined that you want that user to be able to deploy. So obviously once they deploy that as a virtual machine, it's going to contain everything that you've pre-built into it. We spoke about picking a template list. And this template list, it's associated with a particular hypervisor, so you need to have the appropriate template for each hypervisor. You need, there's a built-in OS template within Cloud Platform. You'll see that in a second in the demo. And you can designate them as private or public. So if something's private, for example, only the private template is only able to be provisioned by the user that created them versus something that's public that's accessible to everyone within that zone. So we can register templates. We can register the template wizard. I'll just step through this fairly quickly and out the interests of time. We can register that template here, and there's some options. We can even password enable it if needs be. Sorry, password enabling is basically enabling us to modify the password through a password change script. So you need that password change script installed into that template for it to work. We support different disk formats, so the Zen server supports the VHD format, VMware is the OVA format, and we can select different root disk controller types, NIC controller types, as you can see here, even keyboard types. And for KVM, it's the QCal2 format. Just some information around ISO images. So again, registered in the Cloud Platform in the same way as templates, and you can store virtual machines straight from that ISO image. So actually there should be, before we jump to the summary and quiz, there should have been one more slide in there that was just I'm going to quickly duck over here and talk about registering VMs. So if I go to my Zen server host, I can see now that I've got a couple of system VMs that have been created for the storage and the system VM. So they're already created in my environment. What I want to do is I'm going to log out of here, and I'm going to log in as my Marc TR account. And that was, I think, my company domain. Okay, let's try this again. 1, 2, 3. Okay, I'm sure it wasn't doing this during the practice. Is it Marc TR? Let me just try it like this. Okay, let me do it another way then. For some reason it's not letting me in with that account. So what I'll just do is I'll just do the demo from here. What we should have had, and without spending time debugging this, viewing accounts, I should have been able to log in as Marc TR here as a user of that dev environment. But I'm just going to go through and show you the creation of an instance here as admin. So stepping through this, we have the ability to specify our zone. This is the London zone we just created earlier. I'm going to create a VM from a template. I'm going to create this CentOS image here. These are the offerings, including that extra large offering that I created here. I'm just going to create it as a small instance. I don't need a secondary disk with that as like a data disk. I don't need to worry about any affinity issues. There's only one host in my environment anyway. Here I've got to select a network, so I'm just going to put this on like just a test network. And then I'm going to call it Marc's VM. I can specify the group. I could change any of these settings here if I wanted to change something that I've selected. Then I can launch VM. Okay, that's now going to do all the process of downloading the template from the secondary storage to the primary storage of the cluster, convert that, create a linked clone VDI out of that, create the VM based on the compute offering, and then start that virtual machine. And if I go here, then we should see that VM being created any second. We can see the router that's being created for that network, so that's just been created based on me creating that one VM. So that was also an action that's being created by the cloud. This takes maybe just a few moments for it to take effect, and we'll see the I for the user instance VM that's being created. So just wait for that to come. As always, it's taken a little bit longer. Here's the VLAN that's been then created for that one user, for my test network that I just created as well. This is enabling me to get the sort of tenant isolation, create different users on different networks, and I'll see new networks appear automatically here as well. So it's saying starting that VM. Still not quite started yet, but it's sort of downloading all that from the host, and we can see the internal system name for that VM here as well. So I know that it's going to be I215-VM in that zone, and that's the name there. Still taking a few moments. So let me, in the interest of time, because we're coming up to the top of an hour and a half, I'm going to now jump back to the summary and quiz. So very briefly, I just want to talk about resources. Hopefully this has been very useful for you. There is a wealth of resources available on the internet, such as information about building your own cloud, new resources and support from Citrix. There is a 90-day free trial available of Cloud Platform, so do have a look at that link. Remember, you'll get all these slides and the links in the follow-up email, so you'll be able to get all this later. This masterclass has been recorded. It will be available later as a demo, a downloadable recording that you can watch, and you'll also get the deck that you can download as well. Lots of ways of following us on social media from Twitter, Google+, LinkedIn, Facebook. So do follow us there. On an educational perspective, there's some courses here, implementing Citrix Cloud Platform 4.3, powered by Apache Cloud Stack. That's the CCP 300 course. There's also a CXS 203 Citrix Zen Server 6 administration course, and also a free practice exam there. You'll be able to sort of follow those links. In summary, hopefully this has been useful for you. Hopefully you can see how you can very, very quickly, with the Citrix Cloud Platform product, deliver an out-of-the-box functional cloud for your organization. Something that can handle all areas of operational, service management, and governance, to restrict what people can do, manage what they can do, different types of user accounts, things like that. This is absolutely customer proven. We've got over those 250 plus production clouds driving real world businesses across service providers and telcos through to enterprises, universities, and government businesses today. So with that, I will hand over to Gene.
Time to give away some money. So first of all, to our friends at NetApp and Shape, close your eyes for 30 seconds and give somebody else a chance.
Yeah, you guys are on this a lot, so hopefully we'll see a different winner this week.
So let's show our quiz question. VLANs are used as the isolation technology within which cloud platform zone type?
Enter your answer into the chat window now. The first one with the correct answer. I know it's a tough question. It's about as tough as it gets with Cloud Platform. So do we have anyone that's answering it correctly yet?
I don't see it in my chat window.
It's in the questions window.
The whole window, sorry.
Oh, okay. Great, we have an operator error now.
Whilst Gene looks for his poll question.
Only one thing I had to do.
Can you see the... Okay, I can see, sir. Yeah, there's plenty of people that have answered it here. I'm just finding the first one. Oh, we made this one too easy, I think, Gene. So we have, there's plenty. Excuse me, I'm just, there's so many answers here. I'm just scrolling up to see who is the first one. And I think we have Prashant is the first one with the correct answer, which was advanced zones. So well done, Prashant. Gene will be in contact with you to get details from you and basically get you a $50 Amazon voucher.
Congratulations.
Congratulations. So we've run out of time for today. It looks like there's been, I've not really been looking at it, but I've seen the two Cloud Platform PMs with their heads down for the entirety of this masterclass session, furiously typing at the keyboard. So I think there's been plenty of questions going throughout the session. If there are any questions that we haven't yet covered, don't worry, we will be completing those questions and getting back to you beyond this session. So I'd like to, at this point in time, say thank you very much for attending this masterclass. Hopefully it's been useful. Do remember, if you liked it, tweet about it and mention my name. If you didn't like it, certainly don't mention my name in the tweet. Hope to see you again on another masterclass. At this point, I think we'll draw it to a close. Thanks again. And someone else for my Twitter name is @Marc Trouard-Riolle, which I will.
That's a really
jump. Yeah, I know it's a really easy one. Let me jump to the front slide here, just so you can see my Twitter name. There it is. There's my Twitter name. Positive comments only, please. I prefer it that way. All right, thanks everyone. Bye bye.